For today's video, we will talk about series and mathematical induction. What is a series? It is the sum of the finite or infinite number of terms in
A series can be written as a list of numbers or as a sigma notation. For example, we have 4 as the upper limit, n equals 1 is your lower limit, quantity 3n plus 1 is your term, and your sigma notation.
What is a mathematical induction? It is a mathematical proof technique used to establish a given statement or conjecture for all natural numbers consisting of 2 steps, the base case and the inductive step. So to do mathematical induction, first we'll be given an arithmetic sequence. So let's start with 3 plus 6 plus 9 is 12, all the way up to n. For proving, we have to look for the general term and the partial sum of a sequence formula, which is the a of n and the s of n. The formula for this is a of 1 plus n minus 1 times d, and s of n is n over 2 times a of 1 plus a of n. To get a of n, we'll be using this formula where a of 1 is the first term of the sequence and d as the difference of the sequence. So it will become a of n equals 3 plus n minus 1 times 3. So we'll have to add the common terms and we'll end up with an answer of a of n equals 3n. So if n equals n over 2 times a of 1 plus a of n, we'll have to substitute a of 1 and a of n. So a of 1 has 3, which is here, and 3 of n, which is our a of n. So we'll distribute 3 plus 3 of n to n over 2, which will give us s of n equals 3n times n plus 1 over 2. After that, we will now move on to mathematical induction, which is proving. And this is the statement we have. The first thing we'll do is the base case. This is verifying that n is equal to 1. So verify n equals 1. To do this, we'll use 3 will be equal to 3 of n times n plus 1 over 2. So copy that. Next is that we will substitute n with 1. So this becomes 3 of n times 1 and 1 plus 1. All over 2. So we will get 3 times 1 is 3 times 1 plus 1 equals 2. After that, so 3 times 2 is equal to 6. It's over 2. So now it's 3 equals 3, which proves that 3 is the first term of the sequence. The next step is induction step. So what we'll do here is assume n is equal to k is true. So what we'll do is substitute n with k. So now it becomes 3 plus 6 plus 9 plus 12 plus 3k, because we substituted n here with k, and same goes for the.
After we have assumed that n is equal to k, we can now prove that n is equal to k plus 1. So all we have to do is just substitute n with k plus 1. So you get 3 quantity k plus 1 is equal to 3 quantity k plus 1 times quantity k plus 1 plus 1 over 2. So all we have to do is just solve and combine like terms, and we can get to the equation 3k squared plus 9k plus 6 over 2. So we have now found our s of n. So we have to make sure that our s of n is equal to the other equation. So we now have assumed that this is equal to this. So all we have to do is substitute this. So it's 3k times quantity k plus 1 over 2 plus, which is 3 times k plus 1 equals 3k squared plus 9k plus 6 over 2. All we have to do is just combine like terms and solve for it. And in the end, we get 3k squared plus 9k plus 6 over 2, which is equal to 3k squared plus 9k plus 6 over 2. And therefore, this is true. Okay, so for another example is, we have an arithmetic sequence, 11 plus 15 plus 19 plus to the nth term. So we're going to be using the same formula again. A of n is equal to A of 1 plus quantity n minus 1 times d, where A1 is your first term and your d is the difference. And so 11 is your first term plus quantity n minus 1 times 4. And you distribute 4 to n minus 1, so you get 11 plus 4n minus 1. And so your final answer is A of n is equal to 4n plus 7. Okay, so now we're looking for the partial sum of the sequence. So we're going to be using the same formula like before. S of n is equal to n over 2 times quantity a1 plus a of n, where a1 is your first term and your an is 4n plus 7. So n over 2 times quantity 11 plus quantity 4n plus 7. And so we add like terms. So you get n over 2 times quantity 4n plus 18. So your final answer is S of n is equal to n quantity 2n plus 9. Now that we found A of n and S of n, we can now proceed to mathematical induction. So the first part is the base case. First, we have to verify if n is equal to 1. So 11 is equal to n quantity 2n plus 9. So we just substitute n with 1. So that is why 11 is equal to 1 quantity 2 times 1 plus 9. So we add like terms, so it's 2 plus 9, and then we distribute 11 to 1, and so we get 11 is equal to 11. So the next step is inductive step. So we assume that n is equal to k is true. So we have 11 plus 15 plus 19 plus quantity 4n plus 7 is equal to n quantity 2n plus 9. And so we substitute n with k. So it's 11 plus 15 plus 19 plus quantity 4k plus 7 is equal to k quantity 2k plus 9.
So after getting our S of n, which is 2k squared plus 13k plus 11, we will now prove that this one is equal to 11 plus 15 plus 19 plus k plus 1. So after assuming that this is the same as this, we will just copy this term here and add in our A of n and input k plus 1 as our n. So this becomes 4 times k plus 1 plus 7 is equal to 2k squared plus 13k plus 11. After adding all like terms, we will get the same. And this proves that n is equal to k plus 1. Now that we have assumed n is equal to k, we now have k times 2k plus 9. So now we'll move on to proving n is equal to k plus 1 true. So now the new sequence will become 11 plus 15 plus 19 plus 4 quantity k plus 1 plus 7 is equal to k plus 1 times 2 quantity k plus 1 plus 9. After solving these and adding like terms, you will get 11 plus 15 plus 19 plus k plus 1 is equal to 2k squared plus 13k plus 11.